All right, so taking a look at this first problem, this is practice from what we saw yesterday. First of all, remember that you have to always keep in mind which angle you're going from. In this case, we're told that it's from angle A, so I know I'm going from there. That tells me that the opposite then must be on the other side, so the one that's not touching that angle, and so it's got to be little a. So A is the opposite side. Remember lowercase, because uppercase would have been the angle name. Next up, I actually have a tendency to go straight to the hypotenuse. So I'm going to go ahead and go to the hypotenuse before I go to the adjacent. All right, so for the hypotenuse, it's opposite of the right angle. So yes, that's going to be little c. The other way you can remember hypotenuse is that it's the longest side.
It's pretty high.
Well,
all right, and then finally.
Isn't this a right triangle?
All right, and then that leaves the adjacent. And so the adjacent then, by process of elimination, must be B. But the other way you can know just looking at it is that if I kind of put my finger here at A, I'm touching two different sides. One of them's the hypotenuse, and the other one has to be the adjacent. So it's the one that I'm touching here from our angle that's not the hypotenuse. That's going to be my adjacent side. All right, so in this case, notice this one's going from angle B. So the very first thing I do is I note which angle that is. So if I'm going from angle B, now the opposite, that's the one that angle is not touching. It's on the opposite side, so that's going to be little b. The adjacent, well, that's the one that is not the hypotenuse. The hypotenuse is C, so the adjacent then must be A, little a. Remember, all these need to be lowercase because lowercase represents side lengths, and the capitals are our angles. One little note about this one, I used the same picture, but I switched which angle we are going from. So notice it switched the opposite and the adjacent here, but it did not affect the hypotenuse. The hypotenuse is still whichever one was opposite the right angle here. So that means it's still got to be the same C. All right, and so for this one, we're finding out where the angle measure is for 72 degrees. Bringing us back to how we measure those from yesterday's lesson. Remember, we're always going from the straight to the right. So this is 0 degrees here. And then from there, we always go counterclockwise. So we're always measuring this direction. Now, straight up would be 90 degrees. 72 is less than that. And so we judge it fairly proportionally. So we could estimate that 72 degrees would be about that angle. So we're looking at about this point on our circle. So for figuring out this one, 225 degrees, I start by thinking about, and yes, you really should know these horizontals and verticals right at the start, what all of these end up being, because they help with being able to visualize this sort. Because 225, I start by saying, oh, well, it's got to be between the 180 and the 270. So I know it's somewhere in there. The question is just where in there. And one way to know that, one way, there's actually other ways too, but this is what I'm talking about at the moment, is I could see how far away that is from 180. If I do that subtraction, I get 45. So it's actually at 45 degrees from 180. Well, that's half of 90, right? So it's exactly halfway between the 180 and the 270. So this would be our 225 degrees and where it would end up on our circle. All right, so with this problem, we're asked to find the unknown side length. Well, first of all, notice what we do know. We know this length here and we know this length here. What we don't know is this then. We don't know the hypotenuse of this particular one. Well, and now we need to figure out, how do we know it?
8.
Well, do you remember this?
Wait, no, that's...
Yes, I do.
A squared plus b squared equals c squared. Pythagorean Theorem is what we would use here.
Minus the square root.
Now, when doing this, c is always going to be the hypotenuse. It just happens in this case it's already labeled c. That won't always be the case. We can't depend on that. So remember that it's always the hypotenuse. So if I'm going to actually figure this out then, I'm going to do 6 squared plus 8 squared equals c squared. And a little side note with that, you might be wondering, well, how do I know to do that and not 8 squared plus 6 squared equals c squared?
36 plus
Actually, it's the same thing. Because if I am adding, it doesn't matter which one comes first. So it actually doesn't matter whether we write the 8 or the 6 first. All right, and then we solve this. Well, we've actually solved stuff like this before. Please solve this equation. Figure out what c would equal. All right, and so you can see the work that we ended up doing. A couple of little detail-y things. First of all, it's just order of operations. Do the exponents first. So I square them first, and then I do the addition to get this number over here. Once I get this just to be a number, I want to know what c equals. That means getting rid of the squared, so I square root both sides. Remember that square root undoes the square, which is why we're just left with c. Now, a little detail-y thing. Earlier this year, we learned that when we solve something like c squared equals 100, that we would actually end up getting an answer that was plus or minus square root of 100. So why am I only writing the positive here? Because I'm talking about a triangle here. Can the triangle have a side length that's negative 10? No.
Distance can't be negative.
Yeah, it's a distance, and since distance is always positive, it's got to be just a positive answer. If I were just solving this equation abstractly and didn't have any context for it, yeah, I'd have to include the plus or minus. But because I know that it's actually talking about the side length, it's only the positive. Now for some of you, you're a little rusty on Pythagorean Theorem, which we just used. And so you might want to add this into your notes. You might also want to include with those notes that we can only use our Pythagorean Theorem here for right triangles. If I give you any other kind of triangle, it does not work. But if it works, it's a right triangle. I'd now like you to practice using the Pythagorean Theorem with this problem. Please find the unknown side length in this problem. So in order to solve this one, I'm going to use Pythagorean Theorem. I know that because it is a right triangle. And so I'm going to set it up as 10 squared plus 12 squared equals b squared. Notice in this case, my hypotenuse is named b. It was not named c. But it's still, whatever is the hypotenuse is what it equals being squared. So that's the one that's by itself over there. All right. And then I can go ahead and figure this out. So I do the 100 plus 144 first, because exponents first. And so that gives me 244 equals b squared. Now this is not a nice perfect square like it was before. But I still have to do the square root of it in order to know what b equals. And so actually do the square root of 244. And we end up finding that we get an answer of about 15.62, I'll call it. I didn't say what to round to. If you called it 15.6, that's perfectly fine. And that's our approximate answer for b there. And so that is what we're looking for. Now for doing this problem, it's still a right triangle, and we're still looking for the missing side, so I'm still going to use the Pythagorean Theorem. The only difference is that I'm not looking for the hypotenuse this time. I already know the hypotenuse. And so, when I go and set this up, I'm going to go ahead and do 5 squared plus, oh, well, we don't know what it's called. I'm going to give this a name. I'm going to call it x. You could call it A, you could call it B, you could call it Fred for all I care, but give it a name. And then that equals 13 squared. Because remember, the hypotenuse is always the one that's by itself. All right, so first thing we do is go ahead and square the numbers that we can square. So 25 plus x squared equals 169. Now, I'm still trying to solve this for my x value. So that means I'm going to subtract the 25 from both sides.
That's 12.
So that gives me x squared equals
You're right.
144.
It's 12.
And now we can go ahead and take the square root of both sides. And we do know what the square root of 144 is. Yes, it is 12, and that is our final answer then. The unknown side length here is 12 units long. So in setting this one up, I know the 9, I know the 20. I'm going to go ahead and give the other side a name. I'm going to call it x just like I did last time, but again, you don't have to call it x. You could use a or b or whatever else suits you. So I'm going to go ahead and call this x squared plus 9 squared equals 20 squared. All right, so then x squared plus 81 equals 400. Subtract the 81 from both sides. Notice in this case, because the x has something else with it, that's why I'm having to move it. So we get x squared equals 319, and then I take the square root of that. So the square root of 319 gives me, I'm going to have to round again. I'm going to go ahead and go to 2 decimals, but you didn't have to. It'll be about 17.86. Now, one little detail about this one that might be throwing some of you off. As you take a look at this, you might be thinking, wait, that's more than 9, but 9 was bigger than x was. I never said it's drawn to scale. And that's the thing about these drawings is oftentimes we just have to throw the numbers in someplace so we can kind of visualize what's happening. But you can't depend on your drawing exactly matching. We're just putting it there so we have a visual reference and can remember things like, oh, the 20 is the hypotenuse. Yes, it's still possible for x to be longer than 9 in this case. Now, having done them from a picture, we're also going to be taking a look at how we could do it from words. And so take a moment, write down this problem, and then we're going to work it through as well. So in this problem, we know that the legs of our triangle are 3 centimeters and 4 centimeters. Now, we haven't used that word in here yet, so just to be clear, when we talk about legs of a right triangle, they're the 2 sides that are not the hypotenuse. In other words, the adjacent and the opposite are both also called legs of the right triangle. All right, and so if I'm going to take this picture or this description and turn it into a picture, really this is what I'm looking at. I'm looking at a situation where in my right triangle, I have 2 legs. They're 3 centimeters and 4 centimeters, and I'm trying to figure out how long is the hypotenuse, which I'm going to go ahead and call x again. H might also be a good name for it, for hypotenuse, or C if you prefer. But then we go ahead and set it up. In this case, it would be 3 squared plus 4 squared equals x squared. Because remember, I'm always looking to see which one's the hypotenuse and put it by itself. In this case, it's the unknown. Now, you can go ahead and work this one through, same way as before. When we do 3 squared plus 4 squared, you get 25. And so x ends up equaling 5 here. 5 centimeters to be specific. All right, now continuing with our theme of the Pythagorean Theorem today, the Pythagorean Theorem can also be used to tell whether a triangle is a right triangle or not, because it only works if the triangle is a right triangle. So in this problem, we have some triangle with side lengths that are 5, 10, and 12 feet long. And what we want to know is if it's a right triangle. And so I'm going to plug it into Pythagorean Theorem. The thing, though, is that when I plug it into the Pythagorean Theorem, I know the hypotenuse needs to be the one that's by itself over here. Which one of those, the 5, the 10, or the 12, would be the hypotenuse? It would have to be the 12. If there is a hypotenuse, it would have to be the 12, because remember, hypotenuse is always the longest side in the triangle.
Nope.
And so we would go 5 squared plus 10 squared equals 12 squared. And we are looking to see if this is in fact true. So calculate it out. If I do 5 squared, I get 25, plus 10 squared is 100, and 12 squared is 144. So that's saying 125 equals 144. Is that in fact true?
No.
No, they're not equal. So, is it a right triangle? No. It is not a right triangle because it wasn't true. Now, if I got down to the end and found that the left side did equal the right side, then we would say yes, it is a right triangle. So Pythagorean theorem not only allows us to find sides, but it also allows us to test our triangle. So we'll also see problems like these come up where we're actually finding out something useful about the situation. I mean, that's the point of a lot of the math we do, is to actually be able to use it for some purpose.
Wait.
So in this case, we start by knowing that this guy starts by driving 240 miles west. By the way, you remember which way west is, right?
I would if I had
North, east, south, west.
Actually, it's that way because we're facing south right now.
We live in the northwest. That's another way to remember. You could picture the country and see that we're in the northwest. So this person starts by driving 240 miles west,
South, southwest.
and then he drives 70 miles north. So we're looking at this kind of a situation where he goes 240 and then he goes 70. Notice then we're trying to figure out what is the total distance from start to finish. This is basically our picture then. This is our picture that we're looking at to know what are we trying to figure out. And we're trying to solve for that distance right there. And so this is our setup. When we then solve this through, final answer, you should get an answer of x equals 250.